Welcome everybody. Today in this ANSYS tutorial, I'm going to show you how to model stresses in a rotating ring in ANSYS FEA, and we're going to use a 2D axisymmetric analysis to model the rotating ring. So I already have here an analysis because I actually did this rotating ring analysis uh, previously. So I'm going to walk you through how to set it up in this video, and then in the next video, we're going to compare the ANSYS FEA results to hand calcs. So the first thing I do is I grab the static structural icon here and drag it over to the green dash box. And then if you want to change the name of your analysis, you can left click on the static structural, and actually you can hit the F2 button. So we'll call this stress in rotating disk or ring/ring. And then usually what I do is I go up here to units and left click, and I set my units in the system that I want to work in, which for me, I use US engineering units. So I'll left click that. Now, if you want to set up a material property, you can go here and double click engineering data, double left click. And then here you can right click where it says click here to add new material. If you right click and then left click engineering data sources, we see here that ANSYS provides a library. And so if you would like to choose a material from the ANSYS library, you can left click on the library and you'll see it. There'll be a drop down menu here. So we can add stainless steel when you left click the plus button, and you'll see the bookmark here will show up, and that means that it's being added to your library materials library. Now, for the 2D symmetric analysis, you need to tell ANSYS that you want to do the analysis in 2D. And so the way you do that is you left click geometry and go over here to analysis type, and then left click on the arrow drop down and left click on 2D. And now we need to model our geometry. So I'm going to left click on geometry and then right click. And I prefer using Design Modeler. Again, these options are ANSYS's version of their CAD software that's tied to the ANSYS, I guess, suite of tools. So I'm going to left click on Design Modeler. And you'll see here the CAD window shows up. So to create the geometry, I'm going to make a sketch on the XY plane. So if you left click the XY plane, you'll see it show up here. I want to click on the Z normal vector and orientate my view normal to the XY plane. And you can see here our units are still in meters, so I have to change the units again, and I'm going to use inches. Now, in the 2D axisymmetric analysis for ANSYS, the X vector is going to align with the radial direction, and the Y vector will be the axial direction. So this axis is going to represent the axis of revolution. Now to sketch in the XY plane, if you click it and then you come down here and click sketching, and I'm just going to do a simple ring with a rectangular cross section. So I'm going to sketch I'll click left click and then left click again, and we see our rectangle here is populated. And now I'm going to dimension it. So I'm going to left click general, and I'm actually going to make this 5 inches. So the difference between our inner and outer radius will be 5 inches. And then I'm going to specify the inner radius dimension. So I'm going to left click on the left rectangle and left click on the Y axis. And I'm going to set that to 5 inches. And I'm going to come up here and left click general, and I'm going to specify the thickness to 1/2 inch. And the last thing I'm going to do is I'm going to make a constraint. So I'm going to left click constraint, left click coincident, and I'm going to click on the bottom edge of the rectangle and then also the X axis. And that will align our rectangle coincident with the bottom or with the X axis. And the reason I'm doing that is because what we'll see in the setup is that I'm going to use symmetry. So I'm only modeling half of the thickness of the disc or ring. Now to create the surface body, I'm going to go back to modeling, and I'm going to come up here and left click on concept and click surfaces from sketches. And under base objects, I'm going to expand the XY plane tab and left click sketch and left click apply. And then I'll left click generate. And you'll see the geometry has now been created. So I'm going to save this. Now I'll go back to the main menu, or the ANSYS I guess it's the main menu. And then I'll open up the analysis. So I'm going to left click on model and then right click edit. And the model analysis window will show. And the first thing I like to do is check that the units that I'm working in are the ones I want to work in. And if you go up here to this yellow ruler on the home tab and click it, and yeah, we're in the correct units for this case. Now I like to check and make sure that I like to left click on the global coordinate system and make sure that the geometry is aligned where I expected it to be, and it looks like it is. And then now the first thing I'm going to do is I'm going to left click on geometry, and in this window you'll see 2D behavior. So I'm going to left click and then left click the arrow and change it to Axisymmetric. Now if you left click the surface body here, you can assign the material. So if you click on that and left click the arrow, I'm going to keep it as structural steel. Now for our mesh, I'm going to left click on mesh, and I prefer to use higher order elements because they're more accurate. So I'm going to change the element order to quadratic, and then we'll go back and left click on the mesh and right click insert and left click sizing, and then come up here and click on the face selection, and I'm going to left click the surface body, and here you'll see these yellow boxes. So these are required inputs for ANSYS. So I'm going to left click on geometry and left click apply. And for our element size, I'm going to use a 0.1 inch element. And then I'll right click generate mesh. And there we see our mesh is created. Now I'm going to set up the boundary conditions. So I'll left click on static structural. And this is a rotating ring, so we need to set up a rotational velocity condition. So if you right click on static structural and then go up here and left click rotational velocity, and I'm going to define it by component. So I'm going to click on left click the arrow and left click components. Now you see in the axisymmetric case, this y will be yellow. So if we look at if we kind of look at our global axis or coordinate system, and then I'm kind of orientating this and so that we'll see the rotational velocity plotted here. So if I left click on rotational velocity and I fill this out, so for this analysis I'm using 500 radians a second, and then you'll actually see the I guess it'll show you the arrow in the about the axis that the rotation is occurring. So in this case, the rotation will be about the y-axis, which is what we want because our y vector is associated with the axis of our axisymmetric axis. So this will be revolved about the y-axis. And that looks right. So now I'm going to change the origin of this to 0, 0, 0 because we are running a symmetric case. Now I'm going to insert a boundary condition constraint. So there's two ways that you can do symmetry in 2D. You can either set up a displacement, or you can actually set up symmetry. So in the previous video, I showed you how to do symmetry with using displacement. So you would click on this left edge and insert displacement, and then you'd set your normal vector displacement to 0, or the displacement in the direction of aligned by the vector associated with the plane of symmetry would be equal to 0. So in this case, the y vector is normal to the plane of symmetry, and you want that displacement to be 0. Now the other option is that you can actually set a symmetry boundary condition. So if you right click, insert symmetry, and we'll right click symmetry, insert symmetry region, and then I'll left click the edge and click apply, and we'll change our symmetry normal to y-axis. And so we are all set to run our analysis. So I'm going to insert just some stresses here. And then if you want to solve, you can right click solve. And there we see our results. So thanks for watching, and I hope you guys stick around for part 2 of this video where